All right, now the moment that you've been waiting on, getting into this topic on delivering mid-rise housing solutions. With the housing crisis that Ontario and Canada is facing, we need to react quick if we are going to achieve the 1.5 million new homes over the next 10 years. With labor resources shortages, material supply challenges, higher interest rates, and the act to build homes quicker really opens the door for mass timber for these 4 to 12-story buildings. I'm excited with the lineup we have here today and glad they can share their success stories with using mass timber. If you heard me present in the past, I always stress the importance on using the right team for mass timber projects. It is important to collaborate early in the design stage to maximize efficiencies. It is so nice to have the team here that made the YWCA project a reality. We have Patrick. He is the founder and VP of Market Strategy and Corporate Communications at Element 5, the newest and most technologically advanced CLT and glulam manufacturer in North America and the only CLT producer in Ontario. Patrick's specialty lies in his ability to orchestrate mass timber solutions together with a consortium of the industry's best services providers with experience in mass timber. He is the driving force behind a rapidly growing company that not only manufactures mass timber components, but also provides a complete range of services to successfully execute timber construction projects on a large scale. Patrick believes mass timber is the essential building material of the 21st century, and Element 5 is proud to manufacture their products from sustainably managed local sources. Patrick is a passionate advocate for construction industry transformation and believes that prefabricated mass timber construction is the key to the significant gains in construction efficiency and building performance that we need to meet our significant housing and infrastructure needs in a sustainable way that contributes to a low carbon future. Matt is one of the founding partners of Edge Architects in Waterloo, Ontario. Edge's portfolio encompasses a wide range of project types for diverse client bases. In addition to providing professional consulting services, the firm has been involved in several innovative research and development initiatives. Matt's area of expertise is multi-residential building design with a specific focus on mid-rise, the missing middle, and attainable housing models. His professional interests include modular prefabrication, mass timber construction, and high-performance energy-efficient designs. In addition to being a licensed architect with the Ontario Associations of Architects, Matt is a certified passive house designer and has prior experience as both an energy auditor and small building contractor. Further to his role as a principal at Edge, Matt is a lecturer at the University of Waterloo School of Architecture for the graduate level architectural professional practice course. Matt is himself a graduate of Waterloo Architecture, where his master's thesis was focused on urban revitalization of mid-sized cities using Kitchener-Waterloo as a case study city. Jeff Shantz is a partner of the general contracting firm Melloul Blamey, construction based out of Waterloo, Ontario. The firm was founded in 1982 and is active in public bid, design build, construction management, and property development. Jeff manages project development at the firm and oversees projects from concept to completion. He leads the feasibility process along with project cost, constructability, and material selection for all major projects undertaken. Jeff started with the company in 1993 and quickly took charge of the design build operations and became a partner in 2001. He achieved CCA Gold Seal certification in project management in 2006. Past chair of the board at the Grand Valley Construction Association in Southern Ontario and past member of the General Contractor National Advisory Council at the CCA. In addition to his role at Melloul Blamey, Jeff also serves as vice president at HIP Developments, a company that created to utilize the expertise of the construction company and develop exciting multi-residential projects throughout Southern Ontario. Utilizing the same skill set that resulted in many award-winning projects at Melloul Blamey, he has been able to guide new development at HIP to the same high standards and project success. Jonathan Smegal is based in Waterloo and is an important part of the Building Science Laboratories team. He regularly leads laboratory research, forensic analysis of building failures, hydrothermal modeling, and field monitoring of building enclosure performance. A trusted resource, Jonathan has managed more than a dozen full-scale field tests of wall and roof performances in various locations throughout North America. He has also been involved with numerous new construction site audits for residential and commercial construction, from the design phase through the final walkthrough. Jonathan enjoys the challenges of working on the design and investigations of the building with unique interior conditions such as swimming pools, ice rinks, secure greenhouses, and music stores all over North America. Patrick, I know that was a mouthful. I'll let you take it over from here.
Great, thank you very much, Brock. Leah, let me know if you can see my screen.
All good there, yep.
Awesome. All right, thank you very much, everyone, for joining their presentation today. The title of the presentation is Delivering Mid-Rise Affordable Housing. We wanted to present our YWCA case study, the YW in Kitchener-Waterloo, and provide their perspective of a number of the key players that were involved in that. So Edge Architects as the architect, Melloul Blamey as the general contractor, RDH as the building sciences expert, and then ourselves as the mass timber manufacturer. So with that, let me turn it over to Matt Bolen.
Great. Thank you, Patrick, and thanks, Brock, for the intro. It is exciting to be here today, and there's actually quite a bit of pride I'm feeling right now in being here with this team. This team obviously really does touch on some really key points of expertise and experience on this initiative, but it's also probably important to note that there was a whole big group and consortium of trades and designers that all really were key to being able to execute this project, which, as hopefully you'll see through the presentation, was quite innovative in a number of different aspects in terms of things we were able to achieve. So with that being said, just to give everyone a high-level overview of the project, this project was in Kitchener. It was for YWKW, which is a subsidiary of YWCA, the national branch, and this was transitional housing. So what we did is we assembled a team that was ultimately selected by YWKW as the successful proponent to deliver 41 compact yet accessible one-bedroom transitional housing units. And some of the specific features of the project were modular construction through mass timber CLT and glulam prefabrication, the completion of the design, approvals, and construction within 1 year of contract award. And I think, we'll probably come back to that, and that is the thing that I think probably gets most people's eyebrows popping up the most, just knowing particularly that this went through, that spike in escalation and all the challenges with the pandemic on availability. That was really quite the feat here that, again, we'll talk about a little bit more. There was maximized material efficiency and minimized installation time, obviously, as it related to the above. And another important part of this was the exposure of mass timber surfaces inside the building, inside the units, to impart a sense of warmth and well-being. And that again was one of the key, having been someone along with Patrick specifically who have been involved in and very much interested in the mass timber movement for well over 10 years now, and seeing inroads, showing the Brock Commons project that we saw in the presentation earlier. Some of the things that we have been able to achieve, you start to realize that it's always about incremental gains on a project by project. So just at a high level, I think these were some of the really key and ambitious targets of this particular project that I think we'll show here as I start to flick through some of the pictures now of the completed project, how it was able to be executed. So I will be, I don't have any sort of weird twitch, but my cue for Patrick to be changing slides is to touch my nose. So just so everyone knows, we'll let you inside behind the curtain on that. So yeah, you can see here again, just some of the finished pictures. This is a really good view of the overall site. The project itself was, and I'll get a little bit into the overall team and the entire group of stakeholders outside of our actual successful design build team, which included the region of Waterloo and the city of Kitchener and various others. But you can see here the building that is in the foreground, which was building 1, Also, this picture was taken this past fall, and as you can see there's a second building going up. So we were successful on the first building to the extent that we've actually done a second building now that you can see adjacent. You see behind is actually St. Mary's High School and the Kitchener Public Library as one sort of large building. And you can see that parcel of land that's really bordered by Blockline Road and a number of other more minor streets and roundabouts, that it was really an underutilized piece of vacant land that was city owned. And so being able to capitalize of taking this building type and dropping it in here was quite the feat. One thing also just to note too, before I get into some more specifics on the process, the housing for the building one that you can see, which is a 4-story building, was transitional housing for women battling homelessness. The second building that you can see, the 3-story building, was actually supporting women with children, so families. And so again, that I think for us is one of the exciting things as we start taking our design and the work we've done and all the lessons learned from this case study we're going to talk about today. We are really excited about the idea that we're able to take the standard of design and repeat it and adapt it to different sites, different uses, and that's something that's very exciting for us moving forward. And just an aerial view there. So just wanted to give a high level on the Rapid Housing Initiative. So that's this project for YW was funded through the CMHC's Rapid Housing Initiative. As some of you may be familiar with, the RHI program was first announced for round 1 back in October of 2020, which was around $1 billion of available funding for non-for-profit and supportive services organizations to provide much needed housing for specifically vulnerable populations. So both the RHI program as well as the National Housing Strategy from CMHC really look at a human rights-based approach to housing, and I think for our team, for our firm, that's something we're very much in line with about how we can do that in an inclusive way with our building solutions, so that a certain type of construction isn't stigmatized to one specific type of population. So that was important for us. One thing also about round 1 is there was a requirement, in addition to the 12-month timeline from contract award to occupancy, again, very aggressive. There was also a specific focus on modular construction as part of the round 1 of funding. For us, in this case, we were able to utilize the prefabricated nature of the system out of the Element 5 state-of-the-art facility as meeting that definition. Obviously, there's a lot of different, when people think of modular, they think everything from school portables to shipping containers to, completely finished volumetric modular boxes, and then to ours. So there is sort of a broad definition when you get into modular that we can get into a little bit more. But I think for us, what there is a deep understanding of was that in order to meet the timeline and in order to meet all these complex objectives, there was the need to really pare down the project into the most efficient way to execute something, and particularly when you're talking about these types of infill parcels, there is an importance to not take on too much, to really try to be almost a triage-based approach to solving the challenge at hand when you have tight sites and tight timelines. So just again, from a bit of a background, our initial introduction and relationship with Element 5 started earlier, before this specific project. And as you can see on the left here, this is actually Element 5's R&D facility in Ripon, Quebec, that was in place before the St. Thomas state-of-the-art fabrication facility. And we had gotten into some early work with NRCan, developing some prototypes for long span and high performing panel assemblies. Specifically, those were for office related uses, but obviously we were trying to develop them in a way that they were going to be be able to transition for a variety of uses. And our specific focus was taking some of the testing data on fire that we saw earlier, as well as taking and doing our own mock-ups, getting sound and acoustic testing for vibration and airborne noise and all sorts of other things. So we had a really good team established and had built a really good foundation of knowledge and experience with the systems and products when it came. The next picture is also something that we worked with some supportive service providers in the community that we had relationships with, as well as a local volumetric modular builder at the time. Melloul Blamey was involved with us on this one, which was sort of a backyard. It was almost a prototype modular based solution. And again, that helped to inform some of our knowledge of what modular is, where some of the pitfalls and challenges fall with modular, particularly volumetric. When you're having to connect these boxes together, it doesn't always go great. And so understanding where you saw efficiency through modular and where in fact you actually didn't, and where you created too much risk, that was something that was really well informed as we went into this RHI program. And then generally the two of the projects on the left, on the right hand side for us just represented our knowledge and our interest and our experience dealing with mid-rise built forms, and specifically in the one on the bottom right, affordable and supportive housing mid-rise. So when it came to the announcement in October 2020, that's again where we had that pre-established relationship with Patrick and Element 5. So there was some conversations that we had early. We were also, again, very tapped into the local supportive services provider market, and everyone heard about this RHI funding stream that was coming down. So we started some really early conversations about between Patrick and myself, and then again started expanding the network and group in terms of what could a team look like and what could a delivery model look like for achieving the objectives of this RHI. That when everything came together, and obviously we had Melloul Blamey come on as our really key player, and our general contractor, and our work with Melloul Blamey has often been as that construction manager and someone who really takes that huge amount of ownership in the work. And so they were able to come to the table with a specific response to the RFP request for a CCDC 14 design build, basically a turnkey solution to the funding and the objectives that were laid out by YWCA. And then obviously along with them, with Melloul Blamey and their leadership on the team in that direct contractual relationship with the client, we also, off to the right hand side, we had all of our trades and consultants that were brought on, and not in a conventional way, but actually in a almost, it was an integrated project delivery type of model. Even though we were tied into using the CCDC 14, it was this definite idea that we have to get everybody at the table very early and have that communication and those lines of collaboration really strongly established. And then not only did it stop there, but as you can see up above, and as I already discussed, the region of Waterloo was the source that the funding came through the city stream RHI, and then the city of Kitchener was actually the landowner. And so between the two groups, even though in our multi-tiered system that we have here, it was really essential that they were really at the table, not as something that we were working against, oftentimes where you have approvals authorities, it can be that sometimes some friction there in terms of how to move things through, and obviously a lot of complaints about timing and timelines to get those approvals and get those permits and alternative solutions for different measures. We were able to do that by having them very much be stakeholders in the project, and that helped greatly as well. So again, as you can see, the collaboration and connections between all of those groups we really fostered them and really pushed and promoted them as much as possible. And that was a really key piece. And I'm sure Jeff and maybe some of the others are going to go into that a bit more. So in terms of, again, just the overall process, in order to work backwards from this extremely aggressive rapid schedule of 12 months, we really had to break things down into major sections and major deliverables with timelines associated. And so this was a bit of a infographic that we used, at the table with those groups. Again, not just our internal team, but actually the entire stakeholder group, including the approvals having jurisdiction or authorities having jurisdiction. So really it was about how quickly can we fast track and get through that planning and approvals and permitting process? Then how can we minimize and really make the site work process go as quickly as we can, along with the foundations, right on the heels of that? And how can our design actually be done in a way that does help to streamline that? Same then goes obviously with the superstructure that we're going to see with our time lapse. the superstructure and that rapid assembly of the prefabricated components was a key, really key aspect of the project, and looking for ways that we could make that as efficient as possible, but do it with expertise of the whole team and of the checks and balances. And then finally, obviously leading to the full completion of the project. Next slide. One of the key parts in terms of the mass timber itself was just really trying to optimize the structural properties of mass timber, and having Melloul Blamey on board was really helpful at the early onset, knowing that we had to be competitive in a RFP tender, that we knew our pricing had to be in line with some of the other groups coming in, but yet we did believe that this mass timber solution in this case, because of the timing specifically, if we could get the efficiency optimized through mass timber, knowing that for a lot of us, in the design community, mass timber had at the time been considered a high-end product or an expensive product, that for us we thought if we could capitalize on something as simple as what is the optimal range of the mass timber panels, and how are they supported, and how does that compare to something like, let's say, precast. Melloul, with their extensive experience in working with precast and their historical data that they were able to bring to the table, that was really helpful. And essentially what this graphic here describes is that a typical precast panel with the same optimal length we could do out of CLT, out of Element 5's facility, about 3 times the width, which right out of the gate we're saying that's going to minimize the number of picks off of a crane and cut it by 1/3. And so we knew that we could see that type of an advantage. On the photo here on the right, you can see that in this system too, different from precast, it's actually preferred in mass timber to have multi-point spanning, and it actually helps create more stiffness, more tension, and it is an improved criteria structurally. So again, we were able to use that, roll it into the design, and decrease the amount of mass of product we actually had to use. Same thing was in the stairwells. Obviously on a 4-story and a 3-story, we were able to fully take advantage of, again, that optimized span for our cores and vertical circulation through the space, as you can see here in the finished image. And then in terms of just the overall building layout, you can see, it's a pretty typical slab style building. However, if we go to the next slide, the typical width of that type of a slab would be in the 18 to 20 meter range. Well, in this case, we had a program requirement from YW that they wanted specifically smaller units. And we also had some site restraints of this, vacant land parcel that had some weird geometry to it, and realized if we used both of those things, narrowed the building footprint, we'd actually get ultimately the unit area that we needed, but also do it with a very flexible and adaptable unit layout that, we knew we were going to be able to adjust over time to suit the needs of other types of programs, and also create this ability to have a very comparable apples to apples building layout that we knew would be scalable and adaptable in the future. So again, as you can see, in terms of the unit layouts, one of the really key and important parts of this was knowing that this was transitional housing for women coming from very vulnerable situations. The ability for them to have a door that they could close when they went to sleep was actually really, really important. And it was something that was driven by the client, but also from us. We didn't want these to be, sort of shipping container, bowling alley style units that weren't going to create that sense of warmth and well-being. So one was through the programmatic use of the space, that more squared proportioned unit that would allow us to, not have large, super generous, rooms, but yet rooms that were very functional for the needs of the actual user. And then layering on top of that, this idea of creating the exposure of the mass timber surface in order to get those biophilic advantages, the sense of warmth and well-being, those things for us, seeing very, very literally, the women that are ultimately then coming in and moving here, coming from encampments, coming from homelessness, and us being able to see in real time that value come to life was pretty special. So one thing, obviously, when we, and I won't go into too much detail, just because we did have Vortex Fire Solutions on the team, who offered a lot of expertise and a lot of ability to be able to connect this wealth of testing data. And as Brock went through, that is something that in the industry there is quite a bit of right now. So a lot of times it's about taking that testing data and taking that conceptual understanding of how mass timber performs in fire, and just making sure that there's a comfort with with the building departments and chief building officials. And so one of the key things we did on this project was actually find other projects that had alternative solutions approved, particularly in the GTA, and then made the connections, not just with the documentation, but actually with the personnel, so that the collaboration wasn't just happening between us, it was actually happening between other building departments on various jurisdictions, so that they could understand and get that comfort. And we fostered that type of dialogue. We've continued to do that. So now we actually, it's like every time you bring someone onto the team on the approval side, you actually have an ally and a resource that you can use. And we've since obviously expanded this program and executed it in York Region, multiple projects in Kitchener, obviously, and we're looking to continuously grow that with even a project upcoming in Hamilton with this same team. Acoustics were, I think Jeff might touch on this briefly, but that's one of the areas that's unlike the fire performance. Fire performance, there's been a lot of testing done. There's a lot of documentation available out there. The acoustic performance, particularly of exposed CLT, there isn't actually that much data out there, and that's where, and combating that along with a specific change to the STC and to the OBC classification of residential acoustical performance, where it went from 50 STC basically down to a 47 ASTC, it actually made it challenging for us on the fly. So this was one of the areas where we really had to, in terms of both lessons learned and utilizing the expertise of our team in terms of Element 5, in terms of Melloul, Blamey, in terms of HGC engineering, who we brought on. We ended up having to, in the moment, come up with a way to deal with something called flankage, which is when you have these exposure and you have that structure that I talked about that is spanning over multiple points of bearing, it does open up this ability for sound to flank through those cracks and crevices. And that was something that, again, we had to deal with in real time. And so what we ended up doing was coming up with a somewhat innovative checkerboard design solution where every other unit had either an exterior wall or a ceiling exposed, and that way we were able to, get that advantage of the warmth and well-being that I stressed, but yet also do it in a way that we were dealing with a worst case scenario and a very conservative design. That then what we ended up doing after we were able to do this, we worked with HGC to actually get acoustic testing completed, because the challenge is HGC had to sign off on the design, but yet they didn't have a body of testing data that was robust enough for them to do it without going very conservative. So luckily, we're happy to report that between the testing of this and a few other buildings over the last couple of years, we've actually been able to show that the product performs better, particularly in flankage and exposed condition, than was previously designed to. And so that was one of the great takeaways for us on this project. In terms of the envelope and cladding, there's a lot here, and I'm sure Jonathan will go into some of it. RDH, bringing them on the team on two specific areas, both moisture control as well as envelope performance. That was really key. We had talked in the early days of the project with Element 5 about a completely prefabricated envelope solution that came together, which in this case is shown there on the left with the clips panel. Ultimately, we realized, just because of some of the procurement challenges, some of the fabrication facility setup things, and this timeline we ultimately ended up going with a thickened insulation EIFS system that was very high performing, very high from a very minimal on any thermal bridging. So we knew it was going to be high quality, but it also really limited the number of trades and the number of steps in the process required to do it, which allowed us to ultimately meet the timeline. So that's something I think we're keeping on the boards for us in terms of looking to ways to evolve and refine that, but specifically having RDH on the team, not just through the design process, but in terms of the actual execution on site and the checks and balances that were in place for the envelope, as well as the moisture control, was really key. So finally, when it comes to the BIM coordination, and you can see Kurt, our installer here on the truck, there was a lot of BIM coordination done with actually all the trades and consultants in the early stages on the design, and that was a key component. But I think with specifically this rapid style delivery, what's also really critical becomes that the collaboration in the field. And that was something that was actually really exciting for us. And I think for all of the consultants is that it necessitated us really being there. And again, more that triage approach to all be there at the table consistently. I believe we basically had a weekly meeting that started at the beginning of the project and ended when the project ended. Like that was sort of, there was that consistency to everyone's engagement in this fast track approach that was really unique and exciting for us. So I think I'm going to hand it over to you, Patrick, to just go through the time lapse and before we transition over to Jeff.
Yes, thank you, Matt. So we wanted to demonstrate how quickly we thought the building was going to assemble. So we placed a time-lapse camera on the adjacent building. I'll just let this video play in the background. It's short, it's about 2 minutes. What you'll see is the first day that our materials arrived on site. Within 8 days, you'll see that 2 stories of the building were assembled, and within 20 days, the superstructure of the building was completed. So let me just make sure that the volume is turned down here. And I'll allow this to play.
I don't think it's a big deal, Patrick, but we don't have the volume on here.
Yeah, that's okay. I've decided to turn the volume off. Can you hear me?
Yes, we can.
Great. So here we are. This is day 1, September 23rd. This is the first day that our materials arrived on site. Every panel is pre-cut in the factory. There's no cutting of the materials on site. Here we are, day 8, October 5th, and you'll see 2 stories of the building having been assembled. You'll see our exterior wall panels being erected here soon. Those are about 10 feet wide by about 45 feet tall. And here we are, day 20. So within 20 days, we were able to assemble the entire superstructure for the building. So with that, let me turn it over to Jeff.
Thanks, Pat, and Matt too. So maybe just a little housekeeping. Matt was to speak for 10 minutes, but due to his passion for mass timber, which ultimately, when he came and approached us with Patrick, convinced us to be a part of the YWCA job, and I'll explain a bit on our role. There's a bit of overlap from what Matt had said because he did cover a lot of information there. I'll try to make mine as quick and brief as possible here, but one of the key things that we had done, as Matt had mentioned, we took the lead role as a design build contractor and held the contract for the project, and then manage the overall process. So that was at a high level. Getting into the reason, or what we did most, was basically had to produce the cost. And I'll try to explain to you in very briefly here and about how we went about that. And one of the things there is we worked closely from the beginning with Edge Architects and Element 5 with Patrick and their teams. And that really started, and I'll get to the end of that there in basically a 6-week tender process. But we also equally collaborated with the other consultants, which there were many involved in key trades. After we got started here, we were establishing the building footprint and elevations. We quickly established our mechanical and electrical systems because we needed to understand how we were going to price. We narrowed in on a total electrified solution for all the equipment to minimize the infrastructure required in the building and also simplify other things of costing too. So that was very key at the beginning. Other key features such as the building exterior finish, windows, roofing were also quickly established due to the tender time frame, and we based that on suitability for the project and cost. The interior finishes were established to meet the base owner requirements and also affordability. For the site work, we had many challenges. A lot of the required reports, due to the time frame of the tender call and that, were missing from the RFP. So at least we established measurable allowances in our bid. for such things as site services and tie-ins, and then there was poor soil conditions, so we had to make allowances for that. Another key factor in the success, which I think Matt mentioned earlier there, was the establishment of weekly meetings. And we did that right from the start of the project pursuit. And this was with all the critical consultants and trades to ensure the compliance coordination with the mass timber structure, the building foundations, as well as the mechanical, electrical. And as Matt said, those meetings, we went through right from day one and then quickly carried on when we were awarded the project. So by working closely with everyone, it minimized our overall risk from a contractor, and it made it possible for us to be responsible for the overall cost. As you can imagine, it was an immense challenge to put this all together and provide a fixed price in less than 6 weeks. We were able to achieve this because of the complete flexibility and cooperation we had with the entire team of consultants, trades, and especially the owner and project manager, which Matt touched on also. We were not bogged down trying to meet a stringent specification either in such a short period of time, which was key on this type of RFP. The city and the region were instrumental partners in expediting everything required to get approvals, permits needed to start. And the project to me was a rare example of all parties demonstrating my new term is extreme cooperation. So teamwork was just, it was well beyond that. So the next piece in here, the advantages of modular mass timber to us anyways was easy to see. The one source for the entire main structure and design and the material supply. Anything in our world right now that comes pre-manufactured is something there we would seriously look at. The off-site prefabrication gives you better quality of product, and it's all made in a controlled environment, which it just speeds up the whole process of such a large scale of what the project was of the mass timber. The structure also served as a demising walls, which you saw in some of those slides, in the corridors, and that saved a lot of time too in reframing. We still had lots of other steel stud framing, but that took one piece out of it. The simplified installation of additional load-bearing walls. So like I mentioned there, we just needed some steel stud walls in there to frame out the washrooms and maybe one bedroom wall, but that was minimal compared to what the mass timber had added. The installation, Patrick and I kind of had two versions of that, but there's no question the 20 working days in that video is accurate. It was a few extra weeks in there for a few other things, but no doubt it was amazing to see the time frame that this was put up for the size of building it was. One thing that we felt too, the CLT, it provided excellent surface for fastening of all the products. And that was both internal and external, because we had the exterior skin that we had dense glass and other installations going on. But having a substrate like the CLT, it just simplifies in our building world in here what we can fasten to and what kind of fasteners we use. The obvious piece too there, minimized thermal bridging versus concrete. So the wood is just doesn't conduct like some of those other products. And then in the inside there, you saw some pictures in there providing an excellent finished product. We wanted to really have more finished product, but as we went through the acoustics, which Matt mentioned a bit, some areas had to be drywalled to the new term that I learned, flanking, to eliminate that. But still, it was not a big deal to accomplish that. And as I think Matt also and Pat mentioned, made in Southern Ontario, but I wasn't aware it's the only facility that manufactures in Ontario. So that's pretty significant for procurement and getting the product delivered to your site. Other key points here to address. These are more or less a contractor piece that we look at, what the time of year of the installation is, and looking at winter time, more so too when we'll see the time frames on masonry. This is a little more easy on the time frame because you don't have to deal with a other factors such as rain all the time, because when the building goes up in 6 weeks like it did here, it just takes out that weather factor, because you just don't lose weather from having additional duration. The one thing that you want to make sure is the foundation. In this case in here, we had a slab on grade, and it had to incorporate all the specific anchors. And when that work was done, we had basically a concrete slab when they arrived. It made it very easy for the installation then when all the anchors and that were done properly. The next piece in here, to ensure sufficient moisture protection measures are implemented, and that just because of the wood nature in here, there's no doubt that the CLT is very dense. It's the joints in that you have to be prepared for, and when the proper measures are specified in there with tapes and other types of membranes that can go over, it's very easy to achieve the moisture resistance that you need until you get a roof on. Next item here, to ensure acceptable humidity levels are met before final membranes going on, and that's more of a inspection and testing thing, that you don't get anything locked in for mold to create, and the procedures in there, when they're set up properly, there's no issues. The fire ratings, we did run into just not really any complications, but it was just to be evident in there. We did some exposure of the CLT and the stairwells, which was really nice from aesthetics. But they do require certain fire clear coatings that were put on for flame spread, and then other areas in there too, in the stairwells, under the stairs, and other miscellaneous areas, but those are all easy code checks. Acoustic requirements, Matt touched on that a bit. There is very specific ones in there dealing with mass timber, and it's just to be aware and evident with the team of what you have to do. On the floors in there, we had acoustic mats and also acoustic toppings required for both ratings and transmission. But there again, they were easily managed. Just one of the other items there too, with the walls and ceilings for the acoustics. And I mentioned earlier too, we did apply drywall in certain areas in there, but it wasn't everywhere. And so that we were trying to, on Matt and Patrick's side, trying to expose everything, but that wasn't capable in this. But I think that this particular job did lend itself to testing that's going to help the whole industry, because it was one of the first of its type to go out. So we learned a lot in that case in here, and hopefully in the future more timber can be exposed because of that. In my last slide in here too, just a bit of a comparison on installation time. You can see the load-bearing masonry and hull core and the panelized steel stud and compass floor. We had, in our estimation, it would have been 11, probably maybe closer to 12 weeks for install. With exposure to weather, that can easily grow, because you just lose time also having multiple trades come in. But when this, again, the structure that we did, the size of it in here to be done in 6 weeks, so we could start a roof right away, that just helped us in the overall time frame, probably by about 2 months at least, to get a jump on having the building watertight and finishing inside. And last, the biggest thing there too was the significant advantage to having one trade doing both the wall and floor system and the whole structure. Again, just was a time saver. So, and it was really for us, it was a good learning curve, and now we're full proponents of mass timber construction.
All right.
And I'll hand this over.
Thank you.
To Jonathan.
Yes, my name is Jonathan Smegal. As was mentioned, I work for RDH Building Science, and so I was asked to talk a little bit about the enclosure considerations for CLT or mass timber construction, as well as some of the input we had on site regarding water management as well as design. So first, what value does RDH bring to the project? Well, besides being locally in town, just down the street, which provides a lot of convenience, we have a lot of experience with mass timber over the last several years. Our largest offices for RDH are on the West Coast, and so That's kind of where mass timber in North America reemerged several years ago and has moved over to Ontario after that. So we had a lot of experience on the West Coast even before it came to Ontario. We've had experience in design, construction, walking the site, as well as dealing with lots of different failures and challenges that have emerged as part of this relatively new construction technology. RDH has written a few industry guidelines, including the mass timber best practice and moisture risk management strategies. We've also run multi-day symposiums on mass timber, 2 of them, both one on the West Coast and one in New England area. We've done a bunch of field testing, as was just mentioned. A lot of times we'll take measurements of the wood moisture content during construction to make sure that we are keeping it to an acceptable level. And also before we seal up the wood, we need to make sure that it's not too high. But also we've done field testing, long-term field testing of buildings that have gotten too wet during construction. And, we're trying to monitor those to see what happens, to see if our predictions of how long it takes to dry are accurate. And so on that note, we have also done hydrothermal analysis, using WFI 2D, which is a relatively complicated program, to just kind of predict how long some of these buildings are going to take to dry once they get wet during construction, of extended construction periods. They as you can see from the photograph, this is Brock Commons in BC, and there were definitely some water challenges of that building as the floors went up. It definitely, being 18 stories, it didn't go up nearly as fast as the project we're discussing here did. So there was and it's on the West Coast, so there was a lot more exposure to water, and we learned a lot when we were dealing with that project. Also, right now we have a bunch of CLT in the lab spread out all over with different membranes, wetting, drying strategies, structural testing, concrete, lots of different things that we're learning to help the industry as it moves forward with different water protection strategies, as well as what membranes are best long term. So most of these things have already kind of been touched on, but some of the benefits, there's obviously more than this, but some of the key components listed here are the construction speed, as it's been pointed out. When all of the pieces show up to site pre-cut, pre-made in the right order, you can obviously build a building quite quickly. The carbon sequestration is a big deal. As Brock mentioned earlier, using the BC project as an example, you can make benefits in the CO2, embodied CO2, embodied energy. Exposed mass timber does look really attractive to most people, and so that's obviously another aesthetic benefit that architects and builders are looking for. And the fire control that's been mentioned a couple times. So just in June 2022, there was the full-scale fire test at the Canadian Explosive Research Lab, and that was the photos that Brock showed earlier were from that test, and the results were quite good based on that large-scale test. So some of the challenges with mass timber is that wood is a hygroscopic material and is moisture sensitive, so it will absorb water. And the amount of absorption is dependent on the orientation of the wood. The end grain, obviously, to most people, absorbs more water than the other surfaces, and so we need to be careful about that, and we need to take time to protect it. And it wets relatively quickly compared to the time it takes to dry, both in the individual wood pieces and between, depending on the type of mass timber, between the individual components. So we want to be careful not to trap water into the assembly. And another challenge is movement, not necessarily with large CLT panels where everything's glued together, but with other types of mass timber like NLT or DLT, we can get movement and expansion, which can cause challenges. But in CLT also, if you wet and dry enough, what you'll get is that the individual pieces that are glued together on the different layers will expand and contract separately. And sometimes we've seen over extended periods of wetting and drying that they can start to separate a little bit and leave checks, leave cracks, and separate from the glue. So specifically regarding this project, as it was mentioned, the upper image is kind of a graphic from one of our guides, and the bottom graphic is specifically from this project showing the assembly. One of the nice things about CLT construction is that because of the aesthetic value of leaving exposed CLT on the interior, it often lends itself to the perfect wall construction. And I don't know how many people are familiar with what we refer to as the perfect wall. It was a phrase coined many years ago now by Joe Stiebrick in one of his documents, but it's gone by a lot of other names like the outside insulation technique, or called the persist in the past. And so what it means, though, is that you have the structure on the interior of the enclosure, and then on the exterior of that, you have all your control layers that control water, air, vapor, and then you have your insulation on the outside of that. And so what that does is it controls the temperature fluctuations and extremes of both the structure and the control layers, making them more, improving the durability of those. There's often less thermal bridging because you cover all the ends of the floors and everything that sticks out. And in this case in particular, the insulation and the cladding was an EIFS finish, and it was adhered, which means that there was very, very few fasteners bridging through the insulation. And so there were lots of benefits there. In this case, as was mentioned, I think by Matt earlier, there was 6 inches of EPS foam. And so it's a very high performance enclosure. It can be very airtight because with the air barrier being on the outside of the structure, there's far fewer holes and penetrations in that air barrier system, and they can be more easier detailed in with the air barrier system on the exterior of the enclosure. So you get a relatively highly airtight, highly effective R value of this assembly, which kind of makes it appropriate for passive house or other high performance building projects. One of the other challenges, besides the wetting challenge, is some air control challenges. In this project, because everything was on the outside and it was a fully fluid applied air water vapor barrier, it was not as much of a challenge on this project. But I mean, we've seen a whole range of these types of buildings. And what happens is anytime you have 2 panels coming together, you have a possible air leakage path under pressurization. Pressurization can occur due to mechanicals or due to stack effect and taller buildings. And this can lead to air leakage both through the panel joints, but also in some cases, depending on the panel itself, and if there's cracks between or small joints between the individual pieces of lumber that form up the wides of these CLT, you can get air leakage through those. So you could steel, like for example, if we look down this parapet, this was not the finished parapet. There was a self-adhered membrane that went on the inside surface of this parapet just for this reason. But if you look at the membrane that goes across the roof, the waterproof membrane, and then up the parapet, it is possible if there were joints between those pieces of wood that you could get air movement all the way from the interior to the exterior of the building across the roof system because of the fact that there'd be gaps between the wood. So you need to just take that into account into design and think about that. And that's one of the other kind of the main challenges of these, mass timber, more with dowel laminated and other types where there's larger intentional cracks, less so with the CLT, especially as you can see in the photograph, the joints between the pieces of wood were quite tight. So the greatest challenge to mass timber construction, as has been pointed out, is keeping the wood sufficiently dry throughout the project. It's not that the wood can't get wet at all, but you really need to be careful on how wet and then how often, and give it time to dry. And maybe your assembly allows for drying to the interior, maybe it's vented. So there's lots of ways you can address that. And moisture absorption for mass timber elements is not instantaneous. A long-term or persistent exposure to moisture is likely to be more problematic to the mass timber elements than the overall quantity of water. And so in just some of the different problems that we've observed in the past, and this goes from the left to the right, from a higher likelihood of occurrence to a lower likelihood of occurrence. The most common is just schedule delays. You get water, it damages surfaces, it drips long term. You have to delay certain things because of that. Second, you can get staining. And so I know in some projects, they actually have a budget to go back and refinish the interior wood to take account any dripping or staining that has occurred. You can get mold, obviously, movement, like I had mentioned, and decay. which is obviously an extreme example. We rarely see it, but it can happen. And it's mostly not during construction, but afterwards, if you seal something up when it's too wet and it stays wet for years, you can get eventual decay of the material in that environment. But I mean, these are easily manageable. You just have to start early. And so step one is to complete a moisture risk assessment for mass timber assemblies. And so that's things like identifying climate, expected rainfall, construction schedule, season, length of exposure, type of mass timber, floor or wall, because they will be different. Two would be a type of a construction phase moisture management plan. So it defines all the activities the construction team is going to take to reduce the moisture related risks. And then step three is to execute the design and moisture management plan. And so if that plan is followed, the project will be protected in alignment with the design, construction, development team's expectations, and the entire project team will be well prepared to respond to unexpected, not just expected, but unexpected moisture exposure events. So from in step three with the project construction phase, there are different levels of things we can do. And so it depends on all of those things that we just talked about. There's low protection robustness, which just might be water repellent coatings, targeted protection, tape, sealants at joints, loose laid sheets. There's moderate protection robustness, which we're just gonna, I have one more slide. We're gonna look at a couple examples of these. So water shedding, vapor permeable or impermeable membranes, and then high protection robustness. No immediate action required in a wetting event. The moderate is action required in a timely manner, and low is immediate action required in a wetting event. So we're just going to look at some examples of this based on some of the projects we've been on, and then continue from there. So you can see here we have some low robustness ones down in the lower middle area, where we have some just a tape over the joints of the OSB. On the just to the right of that, we have some sealant. That's actually a laboratory test, but it shows the difference in the sealant side and the non-sealant side of the absorption on the top surface. In the upper right corner with the zip system, that's more of a medium robustness, where you do actually have a waterproof coating within the zip system. Next to that, we have the Smegal membrane, which is another medium robustness. Both of these are quite good on walls, but when you start to put them on floors, you have to remember that they're not a waterproof system. They're meant for water resistant barriers on walls. So they still do require removing the water if it's going to pool, squeegeeing it off, things like that. And then we get into the high robustness. So in the upper middle one there, we actually have factory applied, 2-ply membranes, fully adhered with flaps. You put those down on site, you weld those together, and you don't really need to worry about those unless maybe there's penetrations where different things go through. And in the bottom right corner, they actually went as far as to build a tent over the top of the building to protect that. So there's lots of ways. Moisture is definitely the nemesis of mass timber construction, but we're learning lots. We have lots of strategies, and there's no reason to be concerned if you have a plan and implement that plan.
Thank you very much, Jonathan. So Element 5's role as mass timber manufacturer in the project. The project started as an idea, and Matt mentioned this early on. Matt and I had worked projects together previously, and we thought, if we're able to build buildings cost competitively, we can build them quicker, and we can create these wonderful, healthy environments for people. We thought, well, maybe we have at least part of the solution to Ontario's affordable housing crisis. Secondly, Matt had decided that we would bid this project, excuse me, and he put together the consortium of people to go after it. We became an integral member of the bid process, and then we became a member once we had won that project to meet on a weekly basis throughout the entire project through to its completion. We were responsible for the timber engineering, and that meant deciding on the member sizes, the thickness of the glulam, the thickness of and size of the glulam elements. We designed all of the steel connections, and most importantly, we were involved in the optimization process in order to figure out how to utilize as close to 100% of the standard size CLT panels that we're able to manufacture to minimize the amount of waste and to facilitate constructability and the speed with which these buildings will assemble. Of course, we acted as the mass timber manufacturer to make all of the glulam and CLT components and supply all of the steel connections, and our contract included the assembly of the structure as well. There was a lot of lessons learned. This was the first time that a project of this type, this panelized CLT structure where you're using CLT both horizontally and vertically had been done, and particularly in affordable housing. So there was lots that we were able to learn from this experience. The one thing that we learned was that mass timber is cost competitive. There are many misperceptions when you're working with mass timber, and one of those misperceptions is the commonly held belief that, as a general rule, mass timber is more expensive than other forms of construction. And so that may have been true previously when mass timber components were being shipped long distances, when they were shipped from British Columbia or they're shipped from Europe, for example. But now we source all of our materials within Ontario, we manufacture locally, and we deliver many of our projects locally, which has driven down the cost of mass timber. We chose to go after affordable housing for a number of reasons. And the first is there's a huge need for affordable housing. And between Matt and I, we figured that this is an opportunity for us to make a positive contribution to help overcome the the affordable housing crisis. The second reason why we chose affordable housing was we said, if we can prove that we are cost competitive in the affordable housing space, where margins are incredibly tight, then we felt confident that we could be cost competitive in other building typologies and other sectors of the marketplace. The second thing we learned is that mass timber is fast, and as has been mentioned by the others, this project really came together. It was design, build, tender, and the whole thing came together from the original contract until occupancy in about a year. We were also very surprised at how quickly the superstructure of the building went up. So the core structure of the building went up in 20 working days. But as Jeff mentioned, then there was some additional effort required to finish off that structure for about the next 2 weeks, so 6 weeks in total. We learned, as everybody else has mentioned, the importance and the need to engage early on the project and the importance of collaboration. Other lessons that we learned, the importance of working with a knowledgeable team. One of the challenges with mass timber is it's new to the industry and there aren't a lot of architects or engineers or consultants that know how to work with the product. So when you're trying to propose a mass timber solution and price it competitively against other forms of construction, if you're working with subtrades who are not familiar with it, they always add a risk factor to their portion of the project. And what we know is now an affordable solution. When you get these subtrades that are always adding a risk factor, what ends up happening is you outprice yourself from the market opportunity, and it appears to be more expensive than other forms of construction. So it's really important to work with people who understand this form of construction and how to design, engineer, consult with, and deliver a mass timber solution. We learned the hard way that it's really important to do a detailed scope review and to make sure that you're allocating responsibilities to other members of the team. The one example that I can think of here is we were responsible for the engineering, the delivery, the manufacturing, as well as the installation. And even though we meet on a weekly basis and hammer out all of the details, there's still things that can be missed. And we learn from those mistakes. We do a better job the next time. The one example is when it came to supplying the membrane to cover the joint on the roof panels to avoid water penetration. We just hadn't clearly defined who was responsible for supplying it and who was responsible for applying it. So we ended up having to remove some of the splines to because they had become penetrated with water, we had to remove those and replace them and then apply the proper membranes. One of the issues that we got caught on was commodity price fluctuations, and we had bid this project as a fixed price contract, but by the time we had gotten to the point where we had to buy all of our raw materials, lumber prices had skyrocketed and doubled in about the period of 4 or 5 months. And we got caught on that, and it ended up costing us a significant amount of money to be able to honor our price. It's not so much an issue in projects like RHI projects, because there's a short period of time from contract to delivery. And so as soon as we're awarded the contract, we now go ahead and we buy all of the materials right away. So we're not subject to those commodity price fluctuations. It's more of an issue when you have a project where you're expected to contract really early and not deliver for maybe 12 months or 24 months into the project. We never know what's going to happen with commodity price fluctuations. So the question there is, do we build into our price today the risk of commodity price fluctuations in 12 months or more, perhaps unnecessarily, or do we bid at the current market price? And today lumber prices are actually really good. They're almost at historical lows at the moment. And do we bid at that price and then sort of share the risk over the owner of the project over the long term? So that it's an issue that really needs to be addressed. We've learned that this is not just a off-the-shelf solution and that's it. In order to deliver successful projects, it really means tight integration and an integrated solution of both products and services. And then we've also learned that there is tremendous room for improvement in all of this. Offsite manufacturing of buildings of this type is really at its infancy. This project and others that have followed subsequently have proven to be very successful, but there is tremendous opportunity to mature this solution and just to get better and better at it over time. Matt mentioned our CLIP system, which stands for cross-laminated insulated panels. These are prefabricated envelope panels that we want to apply to the outsides of buildings. And just imagine how much quicker the building would be rendered completely weather-tight and less exposure to moisture if we could supply a prefabricated panel, those 45-foot panels on the outside of the building that come with the CLT layer, the vapor permeable layer, the insulation, the strapping, the cladding, and the windows and doors pre-installed. We see opportunities in the future as the solution matures to include things like bathroom pods and kitchen pods. It's happening more in the US. We don't have a manufacturer that I'm aware of in the Ontario market that makes these. These are prefabricated bathroom pods and kitchen pods that can simply be lowered and dropped into place in these buildings. So that would speed the completion of the interior of this. And also there's tremendous opportunity to improve the overall performance of these buildings. This team that's here today is in fact working on a new version of this building that'll be built to Passive House standard. So we all know that there's a huge need for affordable housing in North America. Pretty much every major city in North America is faced with an affordable housing crisis. We cannot rely on the government to solve that problem. It requires industry leadership, for the industry to take this leadership role in coming up with innovative solutions like we have introduced to this affordable housing project, and innovative approaches to the way in which these buildings are designed, developed, and completed. Because of the population increase and the growth in urban centers over the next 35 years, we know that we cannot continue to build buildings the way we have been for the last 100 years, particularly buildings that take 2, 3, 4, and 5 years to come to fruition. We believe that in order to satisfy the growing demand for housing in Ontario, we need to find a way of industrializing the process. And so what we're trying to do here is to create these repeatable, though adaptable, off-the-shelf solutions in order to reduce overall costs, to make these buildings much more affordable, to increase the speed with which we're able to deliver these buildings, and to increase the volume of buildings that we're able to supply to the need in the marketplace. So that concludes our presentation. On behalf of those who joined us in the presentation, we want to thank you for your participation. We're actually right on schedule, which is fantastic, and I think we've allowed about 10 minutes for Q&A. So at this point, I will turn it back to Brock.
Perfect. Thank you very much, Patrick, and thank you very much, everyone on the team there. It's great to have a presentation from everyone talking about how they their inputs on this project. So for questions, if you can please use that questions Q&A tab up at the top. I don't see any right now. If you're having issues with the questioning, please send me a text message, 519-820-4680. But for a question right now, more for you, Jonathan, is I get asked a lot for what to do for moisture on site with waterproofing and that. And of course, you showed us a lot of great examples. It's hard to have the good, fast, and cheap option, and that's what I keep telling people is you can't have all three. So what strategy did you use on this project here?
The strategy we ended up going with was the Smegal membrane over the entire roof of the building. Although I believe that initially we did have some taped joints, as was mentioned. We were a little late getting that on, and it did get wet, and we had to remove some of the spline structural connections between the panels. But we removed that, put in new ones, and then covered that immediately with the membrane to keep the water off following that. And we did do moisture content readings in the roof just to make sure that they were all in the spline and in the panel itself were all within the recommended values. So that one did end up getting a full Smegal self-adhered membrane.
Perfect. We do have a question here from Vander. Can you share the energy use intensity and or the level of energy savings as compared to the NECB 2015? Matt, do you have any comment on that there?
Yeah, I mean, and as Patrick mentioned, now looking to deploy this design strategy and system to other projects, specifically projects that are either requiring passive or with some of the updates. This first project was done as part of round 1 of RHI. The requirements there were modular and the 12 months. Those were the overarching, particularly in the city stream funding. There really wasn't a lot of specific requirements on energy performance. It was something that, again, through the systems we ultimately did an energy model, just because for as part of our process, but we weren't specifically looking to hit any specific performance requirement in terms of NECB or exceeding the NECB by a certain degree, which now in terms of round 3 of the funding, there are some changes and adjustments there, as well as a lot of the other non-RHI programs through CMHC. Those do have some of those requirements. So we do have the energy model, we do have that assessment, and we could obviously give specifics of that to people as needed, but we weren't specifically looking to hit a specific target on this one outside of just basic code compliance.
Perfect, thanks, Matt. I got another question. It was mentioned that there was no cutting on site. Does this include pre-coordination and shot cutting of all sleeves and openings for mechanical?
I'll touch upon that, and then Jeff, your experience having been involved in everything that was going on site. But one of the nice things about working with Mass Timber and working in a consortium with having all of the key strategic players involved in that and doing a BIM model where everybody's working off the same design, we can incorporate all of the penetrations that are necessary for the mechanical installation in that model. And if we know all of that information, we can pre-cut those openings in the panels in the factory, so that when they're delivered to site, then the mechanical contractors are simply feeding the ductwork and what have you through those penetrations without having to cut them on site. So that then, facilitates the speed with which the mechanical systems are going to be installed. I don't know if anybody else has anything to comment on the actual experience of doing it on site, but that's essentially what we're able to do in the early design process.
Just to add to that, Patrick, like anything 6 inches and under was obviously drilled on site, but even if there was an issue, cutting wood and cutting concrete is two different things. So there was very easy, if there was any minor adjustments to be made, they could be made right away on site.
Perfect. Thank you, Jeff and Patrick. We do have quite a few questions rolling in, so we may not be able to get to all of them, but we'll do our best. We will follow up, though, with everyone on the questions. This one's for you, Patrick, and knowing where you are right today, I'm sure you'll be able to answer this, but is CLT viable in Northern Ontario in terms of delivery costs, remote First Nations?
Yes, we think so. I happen to be in Thunder Bay at the moment. I've just done a presentation to the Thunder Bay Chamber of Commerce to talk about supplying mass timber projects for infrastructure projects here in Northern Ontario. We source all of our materials from Northern Ontario, and they're very keen to see those materials used here in Northern Ontario. So when we look at the numbers and even including the cost of shipping, we are still cost competitive in supplying prefabricated solutions up here. You have to consider things like, there is limited resources in this particular area, limited resources for construction and trades. And the more that we're able to do in a factory environment, relying on the trades, in Ontario, we have more access to those resources, and supply buildings that are further along in construction actually facilitates the construction of buildings in this area. We just won a feasibility study contract to look at the cost comparative between concrete, steel, light wood frame for mining communities. There's huge growth in mining communities here in Northern Ontario, and we've just been awarded a contract to provide a feasibility study to supply mass timber projects to those mining communities. So the numbers all look very favorable, and we believe we can be cost competitive in Northern Ontario.
Perfect. Thank you, Patrick. I'm just going to filter through some of these questions because I know we won't be able to get to all of them. So just trying to figure out ones that will relate to the general group here. So Patrick, what's Element 5's lead times for production right now looking at?
It depends on where the project is in the design process. And so when you're dealing with mass timber, so much work goes into the front end of these projects so that you're putting everybody in a room together and figuring out and addressing all of the issues that may come up through the course of the project to reduce the number of change orders you're going to see at the end of the project. So the mass timber buildings are sort of front end loaded in the design and development stage. But once you get to a design freeze, right now we're probably somewhere between 8 and about 12 weeks, depending on the size of the project. I must point out, though, that Element 5 is really geared to deliver these RHI affordable housing projects. We see them as a way of being able to produce high volumes of these kinds of projects. So they tend to take a priority for us. So when it comes to choosing different projects that we want to do, these kinds of projects are usually escalated to the higher end of the production schedule.
Perfect. Thanks, Patrick. And I think you are also having billets as well too, so so those would be pretty well readily available as well, I imagine. I got a question, maybe for you here, Jeff or Matt. Can you elaborate on the cost competitiveness of this project? Are there cost comparisons between CLT construction versus a more conventional concrete structure? Could you share any metrics that could be used to encourage other future projects to pursue mass timber?
I can comment on part of that anyways, that for this particular project, there's no doubt the size of it in here and the time frame was by far the most cost competitive. Comparably, doing ICF versus load-bearing masonry, as I mentioned, just in my comparison in here, when you pick up 2 months of time alone, that and getting waterproof, just the time alone, even if the price even could be the same, you're doing it 2 or 3 months earlier. Those types of situations in there are definitely the win. So till you get into specifics of how a building's laid out, and that's where Matt and Patrick worked at the start of this for this layout, it was maximized everything. And if you get to odd layouts and other transfer beams and everything else, you're going to have obviously a more costly building. But to be a very general in there, though, this project here by far worked out better as mass timber.
Thank you very much there, Jeff. And we have a question. I know Matt's working on this one right now. Was there any modeling done on embodied carbon of this building and compared to a traditional building? So I'm just going to put this question on pause while Matt digs something up. I'm going to stop sharing my screen. And then we'll let Matt whenever he has a chance. And then another question, this will be the last one after this as well too. Regarding the RFP process, was there 2 separate RFPs, one for consultants and one for CMs, or how was this RFP process done? Maybe Jeff
Matt,
would.
Well, so Matt and Patrick pursued at the start of it in here, but ultimately this particular one was a one RFP for a complete lump sum design build contract. So below Blamey, we ended up carrying all the consultants. In some cases, we married the mechanical and electrical with the consultants and they were one team, but all the rest of the consultants, structural, mechanical, were dealt with us. Matt did deal with some of the fire and acoustics in his team, but we carried the whole thing under one contract. Not necessarily preferable in some cases though too. The more complex of a project, it's very difficult to put together such a refined cost, and that's where the only piece where I would prefer it to be it more mixed and have more information if other RFPs come out like that.
Perfect. Thank you very much there, Jeff. Any luck with that there, Matt?
I'm just having some connectivity issues here getting to the server. So I'll if there's anything else we can, I'll shoot that out maybe subsequently if that's all right. We did definitely do the carbon embodiment. And Patrick, I'm not sure if you have it handy either, but yeah, for sure. You know, in similar way to you expressed, Brock, in your earlier presentation, you know, number of cars off the road, all that sort of thing. We definitely did that analysis. Through Wood Council for these projects for sure.
I was looking through my inbox as well too, because I know Lee sent this to me as well with the embodied carbon calculator. Yeah. But yeah, unfortunately, we're a little bit over time here, so we do got a couple more questions. I will get to them offline. We will do the follow-up with them, and we will definitely put the carbon calculator that was used for this project. But I'd like to turn everyone's mics on to say thank you very much, but I won't. But we really appreciate everyone presenting on the YWCAW. So thank you very much, team. We really appreciate it.
And thanks for the opportunity to present.
Thank you.